I think that permission has not been.
Okay.
Yeah. Now we can
Thank
see
you
your.
so much.
Yeah. We can see your presentation.
I'm going to present a few points about mathematics and
Yeah,
Indian.
sir, you can go to the presentation mode, sir, so we can see your
Sorry?
screen bigger.
Are you able to see the screen?
Yeah, we can see your screen. You can, sir, go to the presentation mode so that, yeah.
Yeah, okay, fine. Thank you so much. I want to share a few points, maybe about 10 to 15 minutes, on the mathematics of what I call the Raga music. Music in our universities presently is taken as a fine arts, and it is dissociated from science. The reasons given are many. They may be right to some extent. Music is, of course, intuitive, emotional, it is instinctive, it is holistic rather than analytical and theoretical. Yeah, that's all true. But it is also known that Indian music has a strong theoretical basis. I'm talking of only the classical music, whether it be the South Indian Carnatic or the North Indian Hindustani, because they originate from the same source. And the best of the music, classical music, what I would call the Raga music, is supposed to be the Alapana, Raga Alapana, which has to be innovative and extempore. As you know, the Alapana has only the sound structure. It doesn't have any language. It doesn't have any accompanying instruments also. But you wonder, what is the tradition which evolved this kind of singing? And that turns out to be highly intellectual. So I'm going to say a few words on that. It is traditionally believed that classical music originated from Samagana, or the chanting of Samaveda, one of the four Vedas. Now, Samaveda, even to this day, is chanted very nearly, if you are able to identify a raga called Karahara Priya in South, which seems to match very closely with what is called the Coffee Thought in North. My intention in this talk is to present only a cross-section of a few points, because the Sanskrit text, starting from the Bharata's Natya Shastra onwards, there are at least about 25 texts which are very important, which cover the theory behind classical music. And they describe, first of all, starting from Bharata.
Professor Iyengar, just 1 second.
Yes.
Professor Iyengar,
Yeah.
your first slide is what is displayed on the screen here. Are you still on the first slide or?
No,
Because
I'm on the second slide.
The slides are not moving. Can you please check? I don't know. What is to be
This
done?
is the second slide. Can you see the page number 2?
No, Professor Iyengar.
So bottom right screen share is what you have to select as what.
Maybe you should share your entire screen.
Would you like to exit and join? Maybe sometimes that works. We don't know.
No, are you able to see the screen or not?
No, we are able to see the screen, but it is the first title screen that is being seen by us for the past 5 minutes.
Oh, I think it is not moving.
It's not moving. Yes.
No, I'm restarting then.
Yeah, you can click on the second slide. You can click on the second one. Oh, you can unshare and then again share, I think. Something, I mean, it has withheld actually.
Requesting remote control of
That's me. If you give it to me, let me see if that helps. Thank you.
approving it. Okay.
Yeah,
It has moved to the
it
second
has
one.
moved.
Yeah, now we can see the slide. Yeah.
Can you enlarge it?
Yeah, we can see.
Yeah, let me see.
Oh, okay, that's fine.
This is good.
That's fine. You can. Okay.
Thank you.
Yeah. So, you see, I was about to say, we have at least 20 to 25 texts in Sanskrit on classical music, the theory of music, starting from an experiment on vibration of strings. It was something very interesting to me because I have spent considerable amount of time studying structural dynamics, as it was mentioned at the beginning, and also vibration and nonlinear vibration. And some of these concepts appear to be very similar. That is why I was attracted to this topic, other than my basic interest in classical music. And, these texts define not only the vibration of strings, because the human voice, if they have to identify the octaves and if they have to identify the doubling of the frequency, what is called the Dvini Bhava in Sanskrit, it would have been possible mainly with the string, because the natural frequency of the string changes as you divide the length, which they would have known from the harp, which was the original veena that was used even by Bharata. But what is more intriguing is they describe Raga Alapana, the structure of Raga Alapana, as though what I may call in modern terms a time series, evolving over a sample space, and with the concept of relative frequency of modern probability theory. This is the last aspect which I want to very briefly present, because it becomes too technical. Are you able to see the next one? Are you able to see the next?
Yes, we are able to see that, yeah.
Okay. Just to fix the ideas, I have shown a table here. The 13 swaras are on this table. Generally, it is supposed to be 7. Some people take 13, some people even do 22. That is only a discretization of the octave or of the interval, non-dimensional if you like, 1 to 2. If you take the interval, closed interval 1 to 2 and divide it into several parts in a particular fashion, we are not going to all those fashions here. What we have to recognize here is there are two different concepts. One is Shruti, one is Swara. Shruti corresponds something like frequency, which is a discrete point, whereas Swara is actually a function of the frequency. For example, it is very common to say Shadja is the Adhara Shruti is 1, then you get Rishabha, Gandhara, Daivata, Pratimadhyama, Panchama, like that. On the Veena, they would say, okay, the free string is Shadja at 3/2, or at the center, you are going to get the Madhyama, which will have the natural frequency corresponding to 3/2. In other words, if I take the basic frequency as 200 hertz, in a modern terms I'm telling, the Panchama would be 300 hertz. So it will be 1.5 times that. But that is only a very simple part of it, because these hertz are only sinusoids. So in a tuning fork, you can get all of them precisely, but in music, you won't get it. And it is not intended either in Indian classical music. On the right side, I have shown 3 graphs. These are actually the free swaras, sa, ma, and pa, as sung by a female voice, a trained musician. Now the spectrum that is shown in the sa, you can see it has around 180 hertz, but it also has other frequencies. Now, if you go to ma, it is going to be 180 plus some 90, it will come to about 230. Then pa, it will become slightly more, it will come to 3/2. That's about 200 to 300, another 50% is added. But that is only on the peak, on the dominant peak. There are also other higher harmonics and also other frequencies which are present. And this is actually what is called swara. Sa is not simply a sinusoid. It is a combination of sinusoids, similarly ma and pa. This you'll have to remember when you go to Alapana, it is not only these 3, but a medley of all these swaras are going to get combined, and in what way it has to be done, is going to be the issue. Now, quickly, I go to Raga. I will not go into all other things. Bharata, in his Natya Shastra, somewhere around 100 BC, some people would claim it was 300. Some people would say, no, it is 100 AD. Whatever it is, at least about 2000 years ago, he defined, he did not call it Raga, but he used the word Jati or Janus to develop the sounds with his 7 or 13 swaras. His definition was, I given it in Sanskrit, which contains 10 characters. That is what he says. The preliminary major characters are lakshanas. The same thing was taken over in the 12th century by Sharangadeva. In other words, you can imagine, for 1,000 years, this classicism has remained same, and to this day it remains same. What are those 10 important qualities? They are in Sanskrit: graha, amsha, nyasa, apanyasa, mandra, tara, shadavita, audavita, and alpatva bahutva. Now there are 10 points here. Now all the 10 points, they are further divided and further subdivided in SR. SR stands for Sangeeta Ratnakara, which is one of the monumental works on classical music of 12th century. And it contains 2 commentaries, one by Kallinatha, the other one by Simhabhupala. They are also equally important. So the theory is very well preserved in these 3 books, which are already about 800, 900 years old. The first 4 characters, that is Graha, Amsha, Nyasa, Apanyasa, they refer to starting, major, that is how do you start the music. Major, which is the main swara. And remember, swara is not just a sinusoid frequency, but it's a combination, it is a sound. Intermediate and ending notes. The next 4 refer to the lower and upper registers. That is what you would call the Tarasthai or the Madhyamasthai or the lower sthai, because it's the registers. So when I said mathematically you can take 1 to 2 as the middle register, then half to 1 becomes the lower register, then 2 to 4 becomes the higher register. These are the 3 registers or the 3 sthais which are generally used. One can in fact go further also, but perhaps for human entertainment or feeling that may not be so useful. And Audavita, Shadavita refers only to 5 and 6 tonal combination, what we call pentatonic and hexatonic. Just to fix it, the South Indian Mohana Raga, the Sa, Ri, Ga, Pa, Da, the 5 swaras, it is pentatonic. Similarly, there are hexatonic with 6, and you can have more also. And they go into greater details about all of this. The whole theory is only the description of this, the interrelationship between the various qualities. And quantification. The quantification comes up in the Alpatva Bahutva. Now, if you take the literal translation, Alpatva means small, Bahutva means more, or less and more, or more or less, like this. Many of the books, they translate it like that also. But the Sanskrit text, they are very clear. It is not as simple as that. This Alpatva Bahutva is actually a probabilistic concept. And that probabilistic concept is what they develop for Raga Lapana through and through as a time series further. Now, you can see that out of this 10, if I leave out Alpatva Bahutva for the time being, the other 8 are all deterministic. You have 7 swaras or 13 swaras. You start with something, you end up with something, you make a collection. So this collection can be combinatory. So Sangeeta Ratnakara, in the initial chapters, he considers Tana, Murchana and Alankar. That means how these can be combined. It is not simply binomial as in Pingala Chandas, it is going to be multinomial. So how k objects can be selected out of n and how they can be combined, and if they are repeated, what happens? If one object is repeated 3 times, what happens? Half the book, he gives all the numbers and all the swaras are listed. The books are available, you can see for yourself. But all these are deterministic because you take sa, ri, ga, ma, pa, da, ni, sa, then you repeat the again. It is a periodic process. Okay, the swaras are there of the combination of the frequencies, but it becomes periodic or it becomes deterministic. So if you say sa, sa, ri, ri, ga, ga, ma, ma, pa, pa, da, da, ni, ni, sa, sa, then again repeat it, it's also going to be periodic again. So it is musical, but it is not yet raga music. So raga music comes up only through this alpatva bahutva property. What is that? Now, Kalinatha explained this very well, even though I will show one of Sangeeta Ratnakara also. Kalinatha takes an example of what Sangeeta Ratnakara has given. That is about the first raga called the Shadji. Shadji is actually from Bharata's time. It is considered the first Jati raga. And the swaras are all written as a table. I have taken the table from a printed book. Even in the manuscripts, these tables are available. So the first line is sa, 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 like that, ni, da, pa, da, ni. Like there are 12 lines. I will not go into details. All these are 7 swaras. Some in the upper register, some in the lower register, some repeated, some unrepeated kind of thing. What does the Sanskrit text say? The first raga named Shadji exemplified through a song with swara prastara. It is not any meru prastara or anything. It is a swara prastara. It is a table of the swaras. Kalinatha in his commentary explains that this example is useful for understanding alpatva bahutva of this raga. Because each raga has its own alpatva bahutva property, and this one example he further illustrates. What he does, atra swara sankhya alpatva bahutva parijnanaya likhyate. I am going to write the number of swaras for understanding of the alpatva bahutva. Shadjaha shatrimshat. The shadjas, the numbers are 36. Like that, he keeps on telling. I have given the table. Ri is 12, Ga is 20, Ma is 8, Pa is 8, Da is 16, Ni is 12. The sum total is 112. He is quite clear. Milita dvadashottaram shatam. So it is in this proportion this raga has to be presented. So alpatva bahuta you can easily see now, because in the modern data analysis, in the parlance, there is a relative frequency, or it is an estimate of the probability of the occurrence of these 7 swaras in this raga, what is called Shadji. Now here, of course, there is a composition also which is given, because these are all discrete. In a book, you can't show continuous thing. So the best that was possible for Sangeeta Ratnakara was the following. He shows 200 ragas as swara series or time series. These are printed. They run for pages and pages together like this. You see that this is a sample time series. They could not give the figures as in time, but they did the best that is possible alternate. Sa, 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 da, sa kind of thing. So sa stands for 1 in the table I showed you in the beginning. So da you can find out the ratio, the swaras, or you can attach a quantity for this. That is the swara value for this you can attach. And this is one way of a bhuta sankhya or a meta language you can say to represent mathematics or to represent the quantity. And he says at the end, iti alapa. It is not a kriti or a tune. It is actually the alapana has to be done like this. So for 200 such samples are available. In fact, samples are so important nowadays, either for rainfall analysis or for earthquake analysis, for so many things. This is a natural, and for any natural phenomenon, you need samples. And this goes back even to a previous training program, and we know that from our even today, a maestro will present in his own way a particular raga as a continuous thing, not as discrete. And Naradiya Shiksha, which is supposed to be a transition between the Vedic practice, the Samagana practice, and the classical practice, says that Vihanganam Tattva Swaragata Shrutihi. Swara and Shruti. Shruti is the frequency. You can't find out the position of a Shruti, the Shruti for a Swara is what he says. And further he says, Swarat Swara Sankramastu Swara Sandhi Manul Banam Avichanam Kuryat Chaya Atapopamam. There is a continuity principle he brings in. Swara to Swara has to be continuous, like sun and its shadow. There can be no break. And the books further continue. I will not go into all those details because they want to make the discrete time series, the discrete mathematics which was described previously, into a continuous one. How do they do it? They keep on increasing the number of parameters. They would call Alpatva as of two kinds, Langana and Anabhyasa. Langana is skipping. Anabhyasa is not repeating the same thing. He defines that also. And he says that Langanam Ishat Sparshaha. Langana is only slight touching. For example, in the Mohana I was mentioning, Sari Gapa Da Sa. When you go from Da to Sa, you have to cross Ni. You can't help it because it has to be continuous. He says the measure that is going to be zero because the person is not intentionally producing the sound. He is simply crossing over that. That is what he says. Langanam Ishat Sparshaha Swarasya Sthana Prayatna Krita Swarupa Nyunata. That is the definition which is given. In other words, I'm trying to give you a flavor of the mathematical terms or the mathematical proxies which are present in this Raga Lapana. The second type of Alpatva is also is infrequence. How many times of numbers? But is it that always they have to be different? No. Equal probability was recognized in a particular Raga called Malavashri. Malavashri Lakshane Swaranam Samatvam Atra Alpatva Bahutva Krita Vaishamya Rahitatvam Vivekshita. They are an equal probability. They have to have equal proportion in a particular time, maybe 5 minutes or 10 minutes it is sunk. There are further variabilities which are brought in kind, Sanchara, Antaramarga and so many things. They are all higher order properties. What I have been talking is only the mathematicians would recognize the first order probability density function. It is only a first order probability, first order description. There are second order and higher order things, which of course is very difficult, but they have tried on the second order. Remaining have been simply left to the imagination of the person. Now, very interesting words they use. Shangadeva says the Alapana should be done, how it should be done, what is the way it has to be done. Stoka stokai statastayahi prasannaihi bahu bangibihi jivaswara vyapti mukhye ragasya stapana bhave. You can see stapana is something like a stationarity. Stoka stoka. Stoka means small thing. In fact, it is the same root, Indo-European root, the avyaya stokashas in Sanskrit, which becomes stochastic in Greek or English or whatever, which also means very small. Prasannaihi bahu bangibihi. This bangibihi is very important. It is the modes. So little by little, the things have to be developed. Because Stoka is also a time variable in Indian mathematics, about 5.3 seconds. So extreme sensitivity in the way that you start, these are all introduced. So the same person, when he sings a raga today and tomorrow, you will feel it different. He is a very good musician. That means there is a sensitivity to the starting conditions, the initial conditions and the development. But all this has to be in the same scale, what is in Carnatic music called Aroha, Avaroha. Aroha is going to be something like a loading. Avaroha is something like an unloading. So people who would know about Hooke's law and all that would quickly say linear elasticity, non-linear hysteresis and all that. Yes, this is a hysterical phenomenon because you go along some particular slope, you come back along another slope, but it has to be in that range only. The 7 swaras, they are defined. So there is an attractor also here. It has to remain within that. Otherwise, people would say, oh, it is an apaswara. You have gone to some other thing like that. In other words, what I have tried to show is the Raga Lapana is actually what the Sanskrit text says, how it is done is a different matter. They want it to be a stochastic process as a castle in air. So it is simply a sound structure which is developed. Did they have any background for this, for 2000 years to develop it? It seems they had. The Vedic prelude has been there. In the Samaveda, the first Sama, if it is taken, it's called, I think, Agnaya Hivite, something it comes. It is developed in 3 different ways. See, very briefly, I have to say a few words about the Vedic Swaras. The Vedic Swaras are slightly different from the classical Swaras. The names are different. What we call in classical Swara, Ma or Madhyama, in the Samagana, it is called Prathama Swara actually. And the Sama scale is a descending scale. There is also ascension is possible, but it is essentially a descending scale. They also have 7 Swaras. There are Prathama, Dvitiya, Tritiya kind of thing. But the important thing is mostly Samagana even to this day happens in about 5 Swaras, except some of the Samas, they go to 6 and 7 also. I will come to that in a second. But the concept here is, in the Samagana, it is only in 1 scale. That is in only 1 raga, whatever raga you may call it. But the tunes or the songs can be different.
Yeah.
Because
Professor Iyengar, you may just try to wind up in next 5 minutes. Yeah.
oh, sure, I will certainly do that. Next 5 minutes. I have only 2 more slides. So the different Sama, the same Sama, what I said, it's called a Gautama Parka or Kashyapa Barhishya or a Gautama Parka in different proportion of mixing the 5 Swaras. So this mixing of the Swaras in different way to get a new thing is already there. And if you go further, if you see the descriptions of how the Sama Veda Brahmanas develop the esoteric and the mystical concept of Samagana, because Samaveda uses the same mantras, mostly the Rigvedic mantras, but not the same Swaras. And if you see any one of the Sama textbooks, there are going to be so many symbols, numbers which are put on the top, below, everywhere, because which Swara has to be used for singing. What we did was, we took a record of that, what is called a Rathantara Sama, which is one of the famous Samas. The text is shown here on the top. The wave pattern was from a person, we recorded it. The wave pattern was converted into a time series through the MATLAB. And, the time series is what I have shown here. And this time series was considered for further analysis of the instantaneous frequencies. That is, the Swara, as I said, it's not a simple frequency, but it keeps on moving. So if I take the instantaneous frequencies and collect them and try to make what Kalinatha wanted to do. Kalinatha had, after all, a finite number of things, and he took the discrete structure. Here I am taking the continuous thing, and because I have the computer at my hand, and for the Rigveda, there are 3, because we know it is a Traiswarya and 3 peaks come up, except in the Kerala Rigveda, it is something very funny. Whereas the Ratantar Sama, there are broadly 5 peaks which come up, the 5 Swaras which can be identified. If you see the classical music, this is again a female voice of a raga called Abhogi. The 5 Swaras can be very easily identified in the way that we are doing. All this based on what Sangeeta Ratnakara and Kalinatha is telling. Yes, this is my last slide, where the Vedic tradition seems to have 2 kinds of things, which is an observational tradition, seeing tradition, which goes into astronomy and mathematics, which Ram Subramaniam and others are going to develop. There is also a Shruti tradition. This music is actually a hearing tradition, which eventually developed concepts, probabilistic and mathematical concepts. So both things are actually originating from the Vedas. This is my last slide. Who is a mathematician? Say, I am attracted to a statement by Hardy. See, Hardy, as you know, a famous mathematician, has a book called Apology of a Mathematician or something of that. I don't remember the title. He says, a mathematician like a painter or a poet, is also a maker of patterns. If his patterns are more permanent, that means if mathematicians' patterns are more permanent, it is because they are made with ideas. He thinks that his ideas are better or whatever, and he is permanent. Now, theory and practice of Raga fits into the above characterization. It is an ideated sound structure, actually a castle in the air, but as permanent as a mathematical theorem, because the Ragas are, whether it is going to be the Hindustani Malcounts or Ayar Bhairav or Darwari Kannada or the Carnatic, Bhairavi or Shankaravarna, they are all fixed already. They are like theorems. So Raga music is an oral time series independent of articulated language. It is not dependent on Sanskrit, let's understand. It has its own language, but its own mathematical grammar made eminently enjoyable. It is a tangible intellectual heritage bequeathed to us from the Vedic oral tradition. Thank you. Sorry.
Thank you. Yeah. Thank you very much, sir. So it is really wonderful to know that Raga is actually fitting into a very good probabilistic pattern. Actually, I actually work in probability and statistics. So it is very interesting to see the distributions coming in there, the discrete distributions as well as the stochastic process. It's really wonderful. So maybe we can have just one quick question because we are running behind the schedule. If there is any question. Sir, you can stop the sharing of the screen. Yeah.
Okay.
Yeah. Yeah, Professor Ramji has one question. Yeah, you can ask your question from here. Yeah.
I'm not hearing.
Professor Iyengar, I just wanted to ask you, the pattern that you displayed for Abhogi Raga, will it be the same thing that you would get if you do it across musicians?
The ratios would have to remain same. The frequencies will be different because, as I showed you in the first table, Shadja is taken as 1.
Correct.
Then with reference to that, the remaining will be there. Yeah, it has to be nearly. We haven't done that well because it involves tremendous amount of computations.
Correct. That's why I was asking. So I thought that there could be some slight variation even in that.
It will.
Okay. Yeah. Okay. And the short G that you said, so should that be interpreted as something which is derived from Shadja?
That I don't know.
Okay.
Perhaps it is, I think, the Shadja Grama of the Bharata Tirtha Shastra, because there are, I didn't want to get into new technical words.
Yeah. No, I understand.
Gandhara Grama and all of that.
Okay.
But he says the first one is short G.
Okay.
So that's something which has come to classical music from Bharata. There are some certain number of canonical ragas. So that is one of them. Since Kalinatha has discussed that, I took it up. It's not necessarily one has to take that.
Okay. So it was really a brilliant presentation. So many of us thoroughly enjoyed it, which you might not have noticed as you are making the presentation. I just wanted to congratulate